everyone, welcome to my channel. In today's video, let's talk about the exceptional case in logarithmic differentiation method. So let's take a look into this problem. Differentiate the function with respect to x, square root of x minus 1 times x minus 2 over x minus 3 times x minus 4 times x minus 5 has been given. Usually, whenever the function is in the fraction form, we will be going for quotient rule. Or if we are having 2 or 3 functions together with the power, like this means you will be trying with product rule using your power rule. Of course, we can go ahead with these rules, but while we are trying with the steps will be more complicated further. If it's 2 or 3 means fine. Sometimes we will be getting 5 or 6 functions together, and in the quotient form also 3 or 4 functions will be on the top, 5 or 6 functions will be on the bottom. So to avoid all those complicated steps, to make the process easier, logarithmic differentiation method is the best way to go for. Let's give a try for this using our logarithmic differentiation method. So as usual, we are going to try. The first step is we need to take log on both the sides. So let us assume first. We'll assume this to be y, so that it will be comfortable for us to take log. X minus 3 times x minus 4 times x minus 5. So now we are taking log on both the sides. Square root is nothing but whole to the power of half. So whenever we are applying log, half comes in front. So half of log of the same thing what has been given in the question, x minus 1 times x minus 2, and on the bottom we are having x minus 3 times x minus 4 times x minus 5. We can take differentiation as the next step, but before getting into that, we'll try to simplify as much as we can using our logarithmic properties. We know the quotient form of logarithmic rule. Whenever we are having log of a over b with the base to be c, it can be written as the difference of logarithm of two functions. So this rule will apply as we are having in the quotient form. Similarly, if they are in the product form, we can express them as the sum of two logarithmic functions. That is also possible. So we'll apply these two things together in our function now. So we'll keep our half outside as it is, and here, as we are having in the quotient form, first we'll try to split them as the difference of two logarithmic functions. So log of x minus 1 times x minus 2, in between we are going to put one minus sign, and then log of x minus 3 times x minus 4 times x minus 5, and we are keeping as it is. Now in this, if you observe, they are in the product form. So we can apply this rule. We can express them as a sum of two logarithmic functions. So we'll give a try now. Log of x minus 1 plus log of x minus 2. Here we are having one minus sign in common. So what we can do, we can write that as a common sign, and we can split them into 3 parts by using our product rule now. So let me introduce one parenthesis. So log of x minus 3 plus log of x minus 4 plus log of x minus 5, and we'll close the bracket as it is. Now if you observe, minus sign is there in common. So if you bring them inside, everything will become negative now. Eventually we will be getting minus log of x minus 4, and here also it will become minus log of x minus 5. So we are simplifying as much as we can. So log of x minus 1 plus log of x minus 2 minus log of x minus 3, and then again minus sign because this sign goes inside. So minus log of x minus 4, negative log of x minus 5. Now we have splitted them into individual logarithmic functions perfectly. Now what we can do means, of course we can differentiate the above function. So differentiating y with respect to x will be getting 1 over y into dy over dx because we are having log y there. So log says we need to write them as 1 over something. So 1 over y into dy over dx, which is equal to half of log of x minus 1 is simply 1 over x minus 1. With respect to x also, if you are doing differentiation, you are getting 1 only. So simply you are getting the term as it is, 1 over x minus 1 plus 1 over x minus 2 minus 1 over x minus 3. And here differentiation of log of x minus 4 is 1 over x minus 4 minus 1 over x minus 5. So we have got our expressions very easily. So because of this reason only we are applying log on both the sides. If we do use our quotient rule, we tend to get the answer, but the process will be tedious and it will consume more time. So to avoid that only we are using this technique. Now what happens means y goes over there. So we'll bring the y over 2. And here no need to take LCM, we can keep as it is, it's fine. We can give the answer in the simplified version. So we can keep as it is. So now y is nothing but the given question. Given question is what actually? So this is the thing we need to write down now. So let me write down everything here. Of course it's quite big. So let me write down. So x minus 1 times x minus 2 over x minus 3 times x minus 4 times x minus 5. And in the parenthesis we will be writing as it is. 1 over x minus 3 minus 1 over x minus 4 minus 1 over x minus 5. So this is our required answer. I hope this video is useful to you. If you like this video, share among your friends and subscribe to my channel. Tap the bell icon for further notifications. Thanks for watching. Until next time, take care.